My name is Jacqueline Rayner and I'm in Math for Teachers 1, going over adding fractions. So for beginning the adding of fractions, we divide up the wholes into, let's say for example, 8 parts. Okay, got 8 parts on that one as well. So each whole is divided into 8 parts, meaning the wholes are your denominators, the total of them. So you bring your 8 across the board. Since it is the same, you take your 8 all the way across to your equal sign. Since it does not change and it's the same denominator that you're adding. Going in to find the numerators, we'll say for example, we've got 3 shaded parts on the first one, so that one is going to be 3 over 8. That's our numerator. And then 4 shaded parts, 4 is our numerator. Since we've already gone across the way and we understand that 8 is our denominator since it is the same, we now just need to add up the numerators. 3 plus 4, and shade those in. 2, 4, 6, 8, or 7, oh, 7, excuse me. And then we've got 7 over 8. So 3 8s plus 4 8s equals 7 8s. Without the picture though, the same thing would apply. You would just bring across your denominators, only add the numerators, and then you've got it, and it's in simplest form. For our next example, let's say we've got a whole plus of 10 plus another whole of 10 equals, of course, if it's the same, a whole of 10 divided up into 10 parts, of course. So our denominators are 10, 10, and of course it stays the same. If it's the same denominators or wholes divided up into the same, it's also 10. So now we find our shaded parts. Let's say, for example, this one is 6 shaded parts. So then our numerator is 6 over 10. And this one is, this one is 2 shaded parts. So then our numerator is 2 over 10. So now we've got 6 over 10 plus 2 over 10 equals, of course the denominator stays the same since it is the same, the ones that we were adding, and we just add the numerators. 6 plus 2 equals 8. So we've got 8 over 10. But looking at that, you can see that it's not in its simplest form. So we've got to say, for example, it says to reduce to lowest term. 8 and 10 can be divided up into this, or can be divided by the same number. 2 can go into both 8 and 10. So what we're going to do now is divide 2 into 10, 8 divided by 2, and then 10 divided by 2. That will equal 4, of course, and 5. Nothing else can go into 4 or 5, so therefore it's to its lowest term. For in this picture though, at the top, we've got our 8 shaded in. Since you can divide that into 2, then you just take that, divide it into 2, and it leaves you with 4/5 in picture form. Now for the next one, because let's say, for example, we're adding more than 2 fractions. more than two fractions. Let's go 4 over 7, 2 over 7, and 5 over 7 equals. We can already automatically see that 7 is right across the board, and it's the same rule for even more than two numbers that you're adding. If it's all the way across 7, then of course 7 is going to stay our denominator. So to make this simple for you on the adding part, so you do not get mixed up with adding the denominators, only add the numerators. We never add denominators. That's a very important rule. So by going into to add all these together and not confusing yourself to add the denominators, make yourself a longer fraction line and bring it down to add the numerators together. So that way you only know to add the numerators and leave the denominator the same. So then of course we got 4 plus 2, 6. 6 plus 5 is 11. So then we've got 11 over 7. Going into that, 11 over 7, because 7 can go into 11, this is an improper fraction. Improper fractions can be reduced to, how many times can 7 go into 11? Once. And then what is the remaining of that? 4. And of course the denominator stays the same. And then we've got our reduced fraction. And then you are done. Thank you.